Today we are going to deal with the theory topic called all air conditioning system, because before moving to the system in HAP, we have this topic all air conditioning system. The reason, because in this project, in this school project, we are going to deal with a package with VAV, and still we have not discussed about VAV system, right, which is related to air side. Okay, so wantedly I put this topic in between HAP so that we can deal with the school project as per the requirement. But the remaining systems like DX system, chill water system, I already covered in chapter 5, right? But this air system is not covered yet, so let me continue with the all air conditioning system before moving to systems in HAP. Because I think, remember, in the last session we learned how to deal with the weather. Then we also discussed about the library in detail, including the schedules. And yesterday we learned about the spaces, right? The next task is creating system. And before creating system, this already explained, you must complete the spaces, because at the time of creating system, you are supposed to link the spaces to the system. Okay, so for that reason, you must complete the remaining spaces, so that when I start system, means not today, tomorrow, because today we have this theory topic, so that I can use that spaces to link to the system. Okay, because without linking the space to the system, you cannot complete the space, because finally the load calculation or the load calculation report, you can generate only by selecting the system, not on the space. Okay, anyhow, you'll get the idea, don't worry. You see the next option in HAP is system. But as I said, before dealing with the system, if you check the input file of your school project, you can notice the system for this project is package, you see, a VAV rooftop unit. And rooftop unit means what? It's a air-cooled package. Generally, in actual practice, rooftop unit means refers to air-cooled package. So air-cooled package is to provide the cool air. But what about this VAV? This VAV is a system related to air side. Okay, so like this, we have CAV, VAV, and duct. So let me complete this systems first, so that you can able to use this VAV system in this school project. Okay, so here in the notes, you'll find this topic in the HAP notes, not in the regular notes, in the HAP notes. If you jump to page number, so you can find in page number 8 in the HAP notes, the topic is all air conditioning system. And all air conditioning system, it not mean that it's a separate system. All air conditioning system, it can be a part of DX system, or it can be a part of the chill water system. In DX system, the air we are going to cool means the air loses the heat directly to the refrigerant, in DX system, right? And in chill water system, the air loses the water, loses the heat to the chill water. Okay, so you'll get the cool air from DX system as well as in chill water system, and you know the difference between the two systems. But now, after getting the cool air from the AHU, how you're going to handle that air? For that, we have this all air conditioning system. It means in the background of all air conditioning system, the cooling effect either with the DX system or with the chill water system. So it's not a separate system. It's a part of, it can be a part of DX or chill water system. Are you getting this point online? Hello?
Yeah.
So now, after getting the cool air from the AHU, how we are going to handle that air? So for that, we have three options. First is a CAV, second is a VAV, and third is a dual duct. Okay, and CAV is not new, you're already aware of that. So in short, we used to call CAV. It's a constant air volume variable temperature system. Once again, You see, constant air volume, variable temperature system. It means the default system, what you already know. I think you already update DX means ductable split in chapter 5. Yes, online ductable split in chapter 5. So if you talk about this ductable split, which I cover in chapter 5 in the video, to the AHU, we are going to connect the duct, and the duct will supply the air to one space or to multiple space, right? Yes, and whenever you switch on that AHU, switch on that unit, all the time through the A terminal. A terminal means it can be a diffuser, it can be grill. The flow rate of air is going to be constant. So it means the normal system. The default system is a CAV. You see, constant air volume. Whenever you switch on the unit, through the duct, the air will supply finally through the A terminal. For example, if I design this room for say 800 CFM, okay. So whenever I switch on the unit, all the time the flow rate of air is going to be same, that is 800 CFM. And beside room, suppose as per the load, I design for suppose 500 CFM, and one more room say 700 CFM. So and all this space is connected with one unit, so one AHU. So when I switch on that unit, that ductable split, or it can be AHU connected to the chill water, whatever. So the flow rate of air from the A terminal is going to be same. Means the normal system. That's the reason we used to call constant air volume. And why we are calling variable temperature system? Because the thermostat connected to the AHU, through which I can increase or decrease the temperature, right? It is possible, na? But the flow rate of air is going to be same all the time. Whenever the machine is operating, whenever the machine is on, means AHU is on, the flow rate of air through the A terminal is going to be same, what you design for, like normal system. But the temperature you can increase or decrease with the thermostat. So the default system, what you already know, that like ductable split or chill water system with the AHU, normal AHU, is a CAV, right? Following online? Yes, sir. So the normal system is a CAV. Okay. And CAV system we can also call as single zone. Why single zone? But before this, do you know the difference between space and zone online? The difference between space and zone? If you don't know, please make a note. I think we discussed this, but one more time, this is a right time to discuss in detail. So please make a note. Space refers to closed boundary regions. Closed boundary region. In general, we used to call room. Room nothing but a space. Technically, we used to call space. In architecture side, we can call room, but technically for mechanical, electrical, we used to call spaces. So space refers to a closed boundary region. Okay. Next point, you can write zone. Under zone, you can write zone refers to thermostat. Zone refers to thermostat. Thermostat means what? In bracket, controlling. So how exactly the zone? I'll explain. We have different possible cases for the zone. Here on screen, for example, here case 1. In this room, I'm going to install one split unit with outdoor. So this is space 1, and for one space, one unit. So this is what? zone 1 means one space, one unit, because for this split unit, separate controlling approach thermostat remote is there. Na? This is one case, first case. Second case, for example, say multiple spaces. To all the spaces, I am going to supply the air with this AHU. And I'm connecting the duct. Through the duct, air is going to supply through the diffusers. These are the branches and say diffusers. So how many spaces in this case? 1, 2, 3, 4, 5, 6. So spaces are 6. Here space is one number only and zone also 1. Here number of space is 6, but number of zone is
1.
Only 1. Why? Because only one controlling through this thermostat. Na? And you can consider this like a CAV system, and whenever you switch on the unit, you'll get the flow rate from this diffuser as per the design. It will not decrease or increase the same flow rate. So it's a CAV system, and CAV system we can call as single zone, because you see for all the spaces the H is 1, so it's a single zone, right? So this also an example for the zone. So zone, don't think that zone is always a set of spaces. It can be one space, one zone, or multiple space, one zone. Okay. Or it can be the mix of both. For example, consider this 6 spaces again. This 4 spaces I'm going to supply with this unit. But this, for this 2 spaces, I'm going to use separate split. So how many spaces? Spaces 6. But how many zones?
3.
3 zones, right? So I think you got the clear idea about the zone, right? And also about the CAV system. Clear online? Now the question is how to... Yes, online?
Okay, sorry. What about just like I'm just a little bit confused with the thermostat, the term thermostat, with whether we is it the same whether we use like a VRF system has in each room you just give it.
VRF is different. VRF is different. Here I'm talking about, you see, VRF means one outdoor, multiple indoors, which I cover in chapter 5. So in that case, one outdoor unit, but connected with the multiple indoors, na? Multiple FCU or AHU, and each FCU or AHU have its own thermostat. So in case of VRF system, number of indoor unit or number of FCU or AHU equal to number of zones. Okay. And next we have a VAV system also, that also we'll discuss. In VAV system also with one AHU you can go for multiple zones, but how we'll discuss next. Let me complete this part first. Okay. Clear online?
Sure.
Now the question is how to decide the zoning. How you will decide the zoning? Whether 2 zone is required, 3 zone is required, 1 zone is enough. On what basis? Yes?
Machine capacity. According to the heat load calculation, we can...
Not exactly. If you talk about this machine capacity or heat load calculation, that is optional in case if that much capacity unit is not available. But remember, the zoning is based on the client requirement or the application requirement. The client asks you to go for, suppose for example, this 4 spaces timing and temperature is same, we can connect with one unit. These 2 spaces timing and temperature is different, we'll connect with a different unit. Okay, so as per the client requirement or application requirement, you can decide the zoning. Okay. Application means say office, and in office, assume that all the suppose a office in complete 1 floor, and you got the information from the client that all the spaces, the timing and the temperature requirement is same. So based on that, we can go for only one AHU if the capacity, that much capacity is available to connect to all the spaces, because only one zone is required. Okay. For example, school, all the classroom timing and temperature is same, so we can connect all this classroom with one unit. But the admin area timing is different, so admin area you can consider a separate unit. So based on the application, right?
Yes, sir.
So you can discuss with the client, because the client may not aware of this. So you can suggest based on the application, you get the information, what will the timing and temperature requirement for different spaces. According to that, you can decide. Okay.
Hello.
Here online? Yes, online.
Sir, in case of in third case, you have separate split AC for two spaces, right?
Mm-hmm.
So in that case, if you supply with a single AHU, both,
Mm-hmm.
like, so at that time the zone will be two zones.
No, one zone. Suppose if I connect with this single AHU,
Huh.
this you can consider as one zone only.
No, overall.
Overall with one, this only?
No, there are two AHU, right? So for space 1 and 2 with AHU 1, space 3, 4, 5, 6 with AHU 2.
Okay.
Two AHU are there.
This is AHU1, this is AHU2. Okay.
AHU 2.
So in this case, two zones.
Two zones.
Two zones. And in this case, space 1 and 2, timing and temperature, if it is same, you can connect with this one AHU. If the timing and temperature is different for space 1 and 2, then you cannot connect. Unnecessary loss of energy. But in this case, this section will consider partition in calculation, because the timing and temperature is different. And I think we already discussed this at the time of load calculation only, this point, right? When the partition is applicable. Clear online?
Yes, sir.
Thermostat की जान सकते हैं.
Pardon? You see, what I explained is related to the CA system. In VAV system, with one AHU, you can expect multiple zones. How I'll show you the next topic. Okay. So these are default in the market, the CAV system. CAV system is one unit means one zone only, whatever the number of spaces in case of CAV system. Okay. Clear? VAV. This is also interesting. This is also very interesting and important as per the market. And if you're dealing with a big project, then VAV is a good option. Or if you want multiple zones, in that case also, VAV is a good option. So what is exactly? In short, we used to call VAV. It's a variable air volume, constant temperature system. You see, variable air volume, constant temperature system. First, let me give you the idea, the concept. For example, I'll give you a simple example. If you take a bucket of water, the cold water, suppose in the bucket, say cold water. And now, for example, assume that in winter season, the electrical water heater in your bathroom is not working. So to get the hot water will manage through the LPG stove. That hot water we're going to mix in the cold water. So assume that here a container on the stove, and we are making it suppose 100 degrees boiling centigrade, means constant temperature water, the hot constant temperature water. This I'm going to mix in the cold water. Initially I'll mix half and I'll check the temperature. If it is okay, I'll start to take the bath. If not, further I'll add, right? So what I'm doing here, by adding the constant temperature water, means the hot water, constant temperature water in the cold water to get the required temperature, right? Similarly, in VAV system, the supply air from the unit is constant, and by increasing or decreasing the volume of constant temperature air, we are trying to maintain the required temperature in the space. You see, once again, in VAV system, from the unit, we are supplying the constant temperature air, say 18 degrees centigrade. But in the room, we are interested to maintain 25 degrees centigrade. So how it can be done? By increasing or decreasing the volume of that constant temperature air. Suppose if I want 18 degrees centigrade in the room, the volume of air from that unit, I'm making it full, like with a valve, and actually with a VAV box. But for example, for learning at this level, consider a valve. So with the valve in the pipe, by adjusting the valve, we can increase or decrease the flow of water. No? Similarly, the VAV box is used to modulate the flow of air or increasing or decreasing the volume as per the room temperature requirement. Getting the idea? It means in VAV system, by increasing or decreasing the constant temperature air, we are trying to achieve the required temperature in the space. Okay, the concept. Now I'll open one line diagram. If you try to read this, you'll get the idea. Try to read this drawing online. It's a plan view, right? In the plan view, you can find this black color is a AHU, cyan is a duct, blue is a VE box, gray is a diffuser. With this reference, try to read this. And find the difference between the CAV and VV. So the first difference here, you see this AHU with VFD drive, variable frequency drive. You know what is VFD drive? Already explained in chapter 5 at the time of VRF or VRV system, right? And the VFD drive is applicable for the compressor, fan motor, and also for pumps, which you will find in model 3 at the time of pump selection. So VFD drive means by default, this is VSD, na? Variable speed drive. And variable frequency drive means by default, it is variable speed drive. And as the speed increase or decrease, the power consumption also vary, right?
Yes, sir.
The first difference compared with the CAV AHU. So in the VAV AHU, you will find VFD drive fan motor. It means it is VSD. It can increase or decrease the speed, the motor speed, and speed is directly proportional to the flow, right? As the flow rate increases, as the speed increases, means RPM increases, the flow rate increases, right?
Yes.
The second difference is inside the duct, you will find a static pressure transducer or duct static pressure transducer, nothing but a sensor which is used to measure the pressure inside the duct and continuously monitor the pressure. Here an example is given here. You'll find on different location and provide the information to this AHU or to the control system, and so that the control system can operate the speed of the fan motor. Why we'll discuss why. But the second, you see the second difference is this static pressure sensor, nothing but a pressure sensor which will monitor the pressure inside and give the feedback to the control system, so that the control system can increase or decrease the speed of the fan motor. Increasing or decreasing the speed of the fan motor means varying the flow rate. Okay, second difference. Third difference is, you see, in case of CAV, duct will directly connect with the branch to the diffuser, but in this case, in between a VE box. VE box, for learning point of view, you can consider like a valve in the pipe. Suppose the water is flowing. With the valve, we can adjust the flow. Na? We can modulate the flow. So here VE box, this VE box to modulate the flow of air. How exactly the VE box? I'll show you. So this is the third difference. Okay. So let me show you the image for the VE box. You see here one example of VE box. Inside you'll find the disc, and to this shaft we'll connect the actuator, means the motors. I'll show you. First of all, inside image. Can you find the disc inside the VAV online? You see this disc with the shaft, and this shaft will connect to the motors, modulators here, this one, and this having link with the room thermostat. Okay. So how the system works? Very simple. Assume that this is office floor. Cabin 1, cabin 2, cabin 3, cabin 4, etc. Assume that the office timing is 9 a.m. Starting is 9 a.m. But suppose cabin 1, some additional, he want to complete some additional work or overtime. So he visit at 8 a.m. only in the morning. and he switch on. Suppose you see this we have a thermostat in the room only, and using the thermostat he will switch on this unit. So what will happen? The H will start with the minimum speed to supply the air only to this VAV, because this VAV is on. This wave will open and give the signal with the control system to the AHU, and the AHU will start with the limited speed to maintain the required CFM for this area. At what temperature? Say 18 degrees centigrade, because constant VAV is a variable air volume, constant temperature system. Na? So temperature of air is constant, say 18 degrees. But you see the user set say 25 degree in the space. So what will happen? And the room temperature initially say 30 degrees centigrade, for example. So this 30 degrees centigrade will sense by the room thermostat and give the signal to VAV. And initially VAV will open the disk fully and supply the complete air with 18 degrees. And what happens? Supplying the 18 degrees with the full opening will start decreasing now from 30 to 29, 29 to 28, 28 to 27, then 26, then 25. So as the temperature decreases, you see continuously this room thermostat will monitor the room temperature and give the signal to this VAV, and the VAV have the actuators now. So slowly what will happen, as the temperature is maintaining in the space, slowly it will adjust and it will start closing. From 30 to 29 it will close slightly, then 28, 27, suppose temperature is attained 25, what you set at 25 it will set to minimum. Getting a point? When it's set to minimum, okay, this is one case. Now assume that at 9 a.m. this cabin 2 and cabin 2 also switch on, because the timing is 9 a.m. Now, so what will happen inside the duct when they switch on? Inside the duct the pressure drops na, because this AH is supplying the air only for this VAV1, but VAV2 and 3 if you switch on, the pressure in the duct will drop, and we have a pressure sensor. The pressure sensor will sense there is a decrease in pressure, give the signal to the control system. The control system will increase the fan motor speed to increase the CFM to maintain the required flow to this spaces also. And the same case happen in this spaces also. As the temperature increases, this will also set to minimum. Okay. Now assume that all the VAV is working now. Suppose at 9:30 p.m. means all the cabin is on. So all VAV is working. So AHU run at full load, for example. And as the temperature is maintaining, it will set to minimum. Then according to that, you see, as it's set to minimum, or suppose one cabin switch off, so it will close, or it will set to minimum. So what will happen inside the duct? The pressure increases. Again, the sensor is continuously monitoring the pressure. As the pressure increases, it will give the signal to the control system. The control system will decrease the fan motor speed to maintain the required flow rate, right? And decreasing or increasing the speed, decreasing the power frequency, and decreasing the power consumption. It means there is no wastage of energy in this. Got the concept online?
Yes, sir.
How the system works? So now the point is, here AHU is only one. So what will be the number of zones? Number of zone, remember, in VAV system equal to number of VAV box. Number of zone equal to number of VAV box, but AH is one. Whatever the number of AHU, but the number of zone in VAV is equal to number of zones. So here 12 zones, right?
Yes, sir.
But you see, for this 2 spaces, 1 VAV. So 2 spaces, 1 zone, as per the timing and temperature requirement. And for 3 spaces, only 1 zone. So you see, this VAV, this VAV is for 3 spaces. So 3 spaces, 1 zone. Okay, again as per the requirement. So got the idea. In case of CAV, number of AH equal to number of zone. In case of VAV, number of VAV box equal to number of zones, because each VAV have its own thermostat. Clear online?
Yes, sir.
I'll play one small animated video. Still, if you have any confusion, you'll get the clear idea with that animated video. Okay. And in that animated video, first you'll get about this HVAC system. Okay. The next part related to VAV. And HVAC system already explained at the time of chapter 5. here one more time revision. And in this animated video, you'll find the chiller as well as boiler and all the AHU components, etc. So let me play this.
Before starting off with the course, I will give you an introduction to HVAC systems.
The audio is audible from the video online.
Yes, sir. Yes, sir.
Yes.
Adi.
Yes, sir.
So let me play again.
Refer to the system shown. There are three main sections involved in this system. They are cooling system, heating system, air handling unit, AHU. The cooling system is used to reduce the temperature of the environment that the HVAC system is controlling. The components of the system are chiller, cooling tower, condenser pump, primary pump, secondary pump. Let us move on to the heating system. This system is used to increase the temperature of the environment that the HVAC system is controlling. The components of the heating system are boiler, primary pump, secondary pump. The third section is the air handling unit. The AHU controls the ventilation and temperature in a building by controlling the airflow capacity. The components of this section are cooling coil, heating coil, air filter, ductwork, supply fan, return fan, inlet damper, exhaust damper, return damper. Let us now see how cooling is provided by this system. The warm water rejected by the chiller is sent to the cooling tower through the condenser pump and cooled. This cooled water in the cooling tower basin is pumped onto the chiller. The secondary pump pumps the chilled water from the chiller to the cooling coils. Fresh air blows in from the inlet damper. This air flows across the cooling coils and its temperature is reduced. The water in the cooling coil takes up the heat from the fresh air blown through it, and this warmed water is sent back to the chiller by pump for chilling. The chill air flowing out of the cooling coils is moved into the ductwork by means of a supply fan. Through the ductwork, chilled air is distributed to the individual zones. The warm air in the zones are sent back through the return fan. A part of this air is sent out as exhaust. The other part is fed back into the system through return dampers to be used for cooling. In case the process is that of heating, the hot water from the boiler is fed to the heating coil by means of the secondary pump. The water passes through the coil, and it is returned to the boiler. The rest of the flow is same as in the case of cooling. Let's start with the first module.
This part for the VAV.
By the end of this module, you will have a basic understanding on VAV application, how it works traditionally, and Danfoss solution. The key benefits of using a VLT HVAC drive in VAV systems. Let me begin by explaining a VAV system to you. Central Variable Air Volume System is a variable air handling system. A central variable air volume system controls the ventilation and temperature in a building by controlling the air handling unit's airflow. That is, The chilled air is distributed to the spaces from an air handling unit, and the temperature of the individual spaces are controlled by throttling the quantity of airflow into each space. But how is this done? Let us refer to the system shown. VAV systems typically bring outside air into air handling units and mix with return air, where the air temperature and humidity can be adjusted. Central fans blow the air across cooling and heating coils into ductwork, which distributes the air throughout the building to all the individual zones. The air passes into each zone from the ductwork through individual VAV boxes. A temperature sensor, located in each zone, modulates the VAV box damper to maintain a temperature set point. The system is designed to maintain constant static pressure in the supply duct and a positive building static pressure by regulating the airflow of the supply and return fans. The static pressure sensor in the ducts transmits a change in pressure to the discharge damper, or inlet guide vanes, through a controller, and the fan capacity is varied to maintain constant static pressure. The fan speed remains constant. Central VAV systems are considered to be the most energy-efficient method to air-condition buildings, because reducing air volume saves both fan motor energy and energy involved in heating or cooling air. Now that you have had an overview of VAV systems,
So I think you got the idea online. Next, so this is about a VAV system. Now we'll talk about dual duct, one more. Not commonly used, but this also one system related to air side. The topic is dual duct. Okay, but before this, some advantage and disadvantage of this VAV. Here you see advantage of VAV: low operating cost. Means there is no waste of energy, as per the requirement. Low capital cost. Capital cost compared with the dual duct, not with the CAV. Compared to CAV, the initial cost is more. Next, individual space control and simple operation, and centralized equipment, central type of AC. Disadvantage, you see all the three disadvantage at what you see: reduce air movements at reduced loads, reduce ventilation capacity at low loads, reduce dehumidification capacity at low loads, and all this disadvantage at reduced loads only. It means, for example, if you design a classroom for 20 people for peak summer, and now assume that only 5 students in the class and the starting summer, so the VAV will set the required temperature and set to minimum for longer time now, because load is less, right? In that case, what will happen? The movement of air reduces. If the movement of air reduces, that causes discomfort, and the pressure also reduces, and the movement of reduces means the dehumidification capacity also reduces. So these are the disadvantage for the VAV, but don't worry, we have some additional attachments. Using that attachment, we can overcome this disadvantages. And what are those advantages? We'll discuss in your project at the time of types of VAV box. What we learn, the VAV box is a normal type. You see, this VAV is a default type VAV box, but you'll find different types of VAV, and the types of VAV I'll explain with your school project, because in the school project we are using a special type of VAV, and at the time I'll explain the different types of VAV, not now. So, and using that additional attachment, one can overcome this disadvantage. Okay. Next we have a dual duct. So the name will give you some idea. Very simple concept. Dual duct means two ducts, right? One is to supply the cool air and one is to supply the hot air. starting with the return air from the spaces. Some air is going to exhaust, equal to what? Equal to fresh air. Say, for example, as per thumb rule, say 30%. 30% exhaust, so 30% fresh air. Okay. For example, as per thumb rule, you know about this ventilation. We discussed now in detail about the ventilation standard. So how much fresh air, that much is going to exhaust. And the return air, the fresh air. This is mixing chamber. Mixing chamber. Here's a filter, then suction of air with the fan, and the air is going to supply the air on the heating coil and on the cooling coil. So you'll get the hot air, you'll get the cool air. And this duct is not connected. If it is connected with insulation, okay, or I'll consider a separate duct with some distance. So here hot air in this duct, cool air in this duct, this branch for cool air, this branch for hot air. You see this branch is running backside of this duct. Okay, this one. It's not mixing here. This branch is running backside of this hot air duct. So hot air and cool air, both is going to supply to the zone or to space with a mixing damper. Mixing damper like a VV box. In VV box we have modulating this disc. Similarly, mixing damper. So this mixing damper have connection with the room thermostat. Suppose in the room, if I set say 27 degrees centigrade, according to that, the hot air and cool air mix, and the required temperature air will supply to the space. Okay, simple concept. And the main ducts will continue again with the main duct, one branch for cold, one branch for hot. Again, both will supply to a space and completely return back to the unit. Okay, so simple concept. Now, if you talk about the advantage of this, the major advantage for this system is quick response in temperature. Quick response in temperature means this is generally for process control. For human comfort, we don't require 1 hour hot air, 1 hour cool air. No? As per the season, we require cool air or hot air. But for process control, consider a machine process. Starting, we require say 32 degrees centigrade. And as per the process, after say 15 minutes or 1 hour, we required say 22 degrees centigrade. So this can be achieved with the system because both the air is available. The required temperature can attain just with the mixing as per when you set in the thermostat. Quickly you'll get the required temperature in the space because both the air is available, right? So the major advantage in this is quick response in temperature. But we have list of disadvantage also. And this is commonly used for process control, not for human comfort, for process. So here you see advantages. Individual temperature control means in this also you can expect multiple zoning. Number of mixing damper equal to number of zones. Rapid temperature response. This is a major advantage. Centralized equipment, simple operation and control. But disadvantage, here you see, initial cost is more because we require a separate system for cool air, separate system for hot air, and we require large space requirement also to run a separate hot air duct, separate cool air duct, large space requirement. And energy consumption, running cost also increases because if you call only for cool air, the hot energy will waste. If you call only for hot air, the cool energy will waste. Okay, but as per the requirement for process control, we can use this. So these are the different systems related to all air conditioning system. Clear online?
Yes, sir.
So generally not used, but important for interview point of view, consider this VAV. And the more about this VAV, like VAV boxes, types of VAV box, we'll discuss with your school project in the next session only at the time of dealing with the system in M.E.P. Okay. So still you have time. You receive that archive file in the evening only. No? So what you do, just retrieve after the class and start working on that and complete all the spaces and send me that and make a archive of that completed with all the spaces and send back with the same email address. So that in next session, I'll open that, I'll retrieve, then start working on the system. Okay.
Yes, sir.
But before this, we'll verify the spaces. When I receive the file from your side, I'll one or two participant, will verify the spaces. Okay. So that you'll get some more idea.